Hermes Managed Tire Services, an IoT-enabled business model. In the cloud, we don't buy computer servers, we don't maintain them, and we just use them. Why then should we buy and maintain tires? Hermes Managed Tire Services presents managed services for tires with mileage-based billing built on Amazon Web Services using Amazon EC2, Amazon Kinesis, Amazon Recognition, Amazon Lambda, and various other services. Let's see how it works. Let's suppose there are two fleets with a few trucks in each fleet. Each of these trucks, we assume, has an edge device, either a Raspberry Pi or similar such device, which is connected to the onboard computer and also reads data from the sensors present in each of the tires. The data from each of these edge devices is transmitted to an AWS IoT engine every 5 seconds. This data from AWS IoT engine is also fed into a Lambda processor, which then sends this data into a PubNub real-time framework, which then builds our dashboards where we have built our dashboards. The data from the IoT engine is also sent to a Kinesis Firehose, which then is fed into a Kinesis analytic application where the data is pre-processed by a Lambda function and sends the data to a Amazon Recognition and then feeds the process data that comes out of the AWS Recognition API into the Kinesis Analytics. The recognition is used to calibrate the road conditions. So if the road conditions are poor, we assume that the truck tire wear is going to be higher. So we actually have a algorithm that takes the road and converts that into a number. The data from the Kinesis Analytics application is then fed into again a PubNub framework, which then helps us build the tire wear dashboard.
We have taken a sample of two fleets with one truck each, and details of both have been loaded into DynamoDB table. We can take a look at one of the truck here, which has initial mileages of the truck and initial mileages of all the tires, and we have the percentage of tread wear for each of these tires. Look at the data generation. I am running the mock data generation program here, so it generates the data. We can see the data in the sample IoT topic here, so the new messages arriving on the topic fleet device data. We have also created a rule engine to send every message on this topic to a Amazon Kinesis Firehouse and also invoke a Lambda function. So this is the sample dashboard, which shows the percentage of tire wear for each the tread of particular truck, and in the down you can see the real-time visualization of the current velocity of the truck. Now we are seeing the Kinesis Analytics application. We can see the input streaming data into the Kinesis Analytics application. We have the load on the vehicle, mileage, temperature. The base 64 format of the image is converted by Amazon Recognition into terrain, and it gives the rank to the terrain as 1, 2 and 3 as good, bad and worst. And this is the base 64 image, and the pre-processed record terrain is available here. Lot of multiple Kinesis queries and in-memory streams. We can see the final feature generation of the mileage, aggregated mileage in a tumbling window, and number of brakes applied within that period of time. Going back to our initial DynamoDB table, we can see the initial mileage has been updated and truck has already traveled 7 miles, and the same 7 mile has been updated to the each tire mileage, and there are some changes in the tread wear percentage.
This is the simplest model of our application, and thanks for giving us this opportunity. Thank you.